Hey everyone, in today's video we're going to be talking about a theorem that we can use to help us out when we're working with isosceles triangles, and it is called the perpendicular bisector theorem. Let's go ahead and let's get started. So if you don't know what an isosceles triangle is, you might want to check out the last video because we talk about what it is and how we can use it and some of its properties to help us find missing sides and angles. In this video today, we're going to be talking about this theorem that specifically has to do with isosceles triangles. So what this theorem says is that if we have an isosceles triangle, and remember an isosceles triangle is a triangle that has two sides that are equal to each other. So essentially a triangle like this where two sides, side AB and BC in this triangle, these two sides are congruent, which is why they have these congruent marks. If we have this triangle ABC, okay, and if it's cut by what we call a perpendicular bisector, okay, if we have a triangle, an isosceles triangle, that's cut by a perpendicular bisector, if this happens, how do we know that it was a perpendicular bisector? Well, these two angles that we have would have to be equal to each other. So if we have an isosceles triangle that's cut by this line right here, and it leaves us with two angles in here that are congruent, okay, if it leaves us with two angles in here that are congruent, so there we have two angles. If those two angles are congruent after being cut by this line, all right, then what we're allowed to say is that this line is perpendicular and that these two sides are equal to each other. All right, so let's go ahead and recap that one more time. If we have an isosceles triangle and there's a line that goes through the middle of it, if that line creates two angles that are equal to each other right here at the top, then we know that this line is perpendicular, so that we know that that line makes a 90-degree angle at the bottom, and that the two sides, so pretty much AB, AD, and BC, those two sides would be of the same length. Okay? And that is the perpendicular bisector theorem. How do we use this? Well, let's go ahead and let's get a problem that's actually going to use this, because a lot of times that's the best way to actually understand the theorem, is to see a problem where it's applied. So here we have this triangle. It's upside down, but we can tell it's an isosceles triangle because we have these two side lengths that are equal to each other. All right, and the question asks, what is the measurement of angle RSQ, and they want to know what is PR, so what is the length of this segment. Well, let's take this piece by piece. So they want to find out what this angle right here is. Well, the only way I'd be able to figure this out is if I can find out what this angle is and what this angle is. All right, or even what this angle was. If I can find this inner angle right here, then I can find what this angle is, and because these two are congruent, I'd know what RSQ is. So here we're going to be able to use the perpendicular bisector theorem because this is an isosceles triangle, and because when they cut it through the middle with that line, because they have these two angles that are equal to each other, we know two things. We know that this is a 90-degree angle, which means the one behind it would also be 90 degrees. And we also know that this line QR is equal to line PQ. I can use this information to help me find this missing angle because I know that inside all triangles, the angles have to add up to 180. So here I have a 90-degree angle, a 31-degree angle, and I can use that to my benefit because I know, so for part A, I know that 90 degrees plus 31 degrees plus that missing angle, we'll call it X. I know that all that together should equal 180. So I can use this, I can go ahead and add these two. That would give me a 121 plus X equals 180. I can then subtract 121 from each side. Minus 121. minus 121. And what we end up getting is that x equals 59 degrees. And because these two angles are congruent, I know that this also has to equal 59 degrees. So I know RSQ, that equals 59 degrees. Part B is a little easier. They want to know what's the length of this line here in blue. Well, if we know from here to here is 4, from Q to R is 4, because of the perpendicular bisector theorem, we know that PQ is equal to QR. This line is equal to this line. So basically, this is two lines that have the measurement of 4. So the whole thing would just be 4 plus 4, meaning PR would just be 8. And this is how we use the perpendicular bisector theorem. It can be kind of a tongue twister to help us solve or find missing angles or missing side lengths. So hopefully now you feel like you understand the perpendicular bisector theorem. Again, this theorem is only applicable to isosceles triangles. Okay, so what I'd like you to do now is practice this. Find some problems, Google them. You'll find some. That's always the best way to make sure you solidify something in your head. If you feel like you got it though, and you're like, nah, I'm pretty confident in myself, check out this next video on equilateral triangles so that you can learn some properties about those and how we use those in geometry as well. Thank you for watching, and I'll see you guys next time.